Welcome to the Aviation Aircraft General Airframe course for the year 2026. Have you ever looked up and wondered how those huge metal birds stay up there? These questions come with full explanations, which will help you get your certification on the first try. Please leave your great suggestions in the comment section below, so I can improve this. Today, we will talk about the main body of the airplane, known as the airframe. I want to help you understand how airplanes are built and how they stay strong. Think of the airframe as the bones and skin of the airplane, holding everything together. It must be very light, but it also has to be incredibly strong for safe flight. We will look at the forces that try to bend and twist the airplane during flight. These forces are called stresses, and the airplane must fight him off every single day. There are 5 main types of stress that you need to remember for your exams. The first one is tension, which is a force that tries to pull things apart. Imagine pulling on a rubber band, and you will understand exactly how tension works right now. The second type is compression, which is a crushing force, pushing things tightly together. If you step on an empty soda can, you are using compression to crush it. The third stress is torsion, which is a twisting force, like wringing out a wet towel. Next is shear stress, which happens when 2 layers of material slide past one another. Finally, we have bending stress, which is a combination of tension and compression working together. When an airplane wing bends up, the top is compressed, and the bottom is under tension. Aircraft designers use special materials to make sure the airframe can handle all these heavy loads. Aluminum alloys are very popular because they are light and they do not rust easily. In modern airplanes, we use a lot of composite materials, like strong carbon fiber plastics. Composites are even lighter than aluminum, and they can be molded into very smooth, curved shapes. The main body of the airplane, where the passengers sit, is called the fuselage. The fuselage holds the crew, the passengers, and all the cargo, keeping them safe and warm. Most modern airplanes use a semi-monocoque design for their main fuselage structure. Today, this means the skin of the airplane carries some of the stress, along with internal frames. Inside the fuselage, you will find bulkheads, which are wall-like structures, providing extra strength. Stringers are long pieces of metal that run from the front of the plane to the back. They give the skin its shape, and they stop the metal from buckling under heavy loads. Now, let us talk about the wings, which give the airplane the lift it needs to fly. Wings can be attached at the top, the middle, or the bottom of the airplane fuselage. Inside the wing, there are long, strong beams, which are called spars, carrying the main load. Ribs are attached to the spars, and they give the wing its special, curved shape. The skin is attached to the ribs, creating a smooth surface for the air to flow over. Many airplane wings also hold the fuel tanks, hidden safely inside the empty spaces. At the back of the airplane, we have the tail section, which is called the empennage. The empennage keeps the airplane flying straight, and it helps the pilot steer the aircraft. It has a vertical part, called the fin, and a horizontal part, called the stabilizer. Moving parts on the tail, like the rudder and elevators, control the direction of the flight. The landing gear is another main part, supporting the airplane when it is on the ground. It has strong shock absorbers to make the landings smooth and keep the passengers comfortable. Brakes are attached to the main landing gear wheels to help the airplane stop quickly. Aircraft windows are usually made of strong, clear plastics rather than heavy, normal glass. They are built to handle the difference in pressure between the inside and the outside. The doors are designed like plugs, so the high pressure inside seals them tightly shut. We must inspect the airframe regularly to look for cracks, damage, or tiny signs of rust. Mechanics use special tools to check places that are hard to see with just the naked eye. Keeping the airframe clean is also a big job to prevent dirt from causing damage over time. If we find a problem, we must fix it right away before the airplane can fly again. Safety is the most important thing in aviation, and a strong airframe is the first big step. You must know all the C parts and how they work together to pass your tests easily. I know this sounds like a lot of information, but we will take it step by step. Let us break down the materials a bit more so you can really understand the choices. Pure aluminum is very soft, so we must mix it with other metals to make it hard. When we mix metals together, we call the new, stronger metal an alloy, which is very useful. Titanium is another great metal, because it handles very high heat near the hot engine areas. However, titanium is very expensive, so we only use it where we really need it most. The wings have moving flaps on the back edge, which help the airplane fly at slower speeds. Ailerons aerials sew on the wings, and they help the airplane roll from side to side. When you turn the control wheel, the ailerons move up and down to change the flight path. Thenno's landing gear can be steered, so the pilot can drive the airplane on the runway. Most commercial airplanes have tricycle landing gear, meaning one wheel in front and two in back. This makes the airplane much easier to handle when it is moving on the ground. Let us talk about corrosion, which is a fancy word for rust on metal aircraft parts. Corrosion can eat away the metal, making the airframe very weak and dangerous for flying. We use special paints and chemical coatings to protect the metal from the wet weather. Water is the biggest enemy, so we make sure the airplane has tiny holes to drain water. Mechanics look for white powder on aluminum, because that is a clear sign of bad corrosion. Regular maintenance checks fix these issues early, saving money and keeping everyone completely safe. The flight deck is the front area where the pilots sit and control the entire flight. It has all the main instruments, computers, and screens to show how the airplane is doing. Behind the flight deck, the passenger cabin must be pressurized so people can breathe normally. As the airplane climbs higher, the air outside gets very thin and cold, lacking enough oxygen. The airframe must hold the extra air pressure inside, just like a blown-up party balloon. Every time the airplane goes up and down, the metal skin stretches and then shrinks back. Over many years, this constant stretching can cause metal fatigue, which is a serious problem. Fatigue is like bending a paperclip back and forth until it eventually breaks in half. Engineers test the airframes for thousands of hours to make sure fatigue does not happen early. They use computers to simulate flights, checking every single part for potential weak spots. Train, test, we need to fix, repeat, is the best process for making airplanes better. Remember, the airframe is the main foundation, and everything else is attached directly to it. If the airframe is weak, the engines and computers will not matter, because the plane cannot fly. I hope this helps you see how amazing aircraft engineering truly is in the modern world. 1. What is the main body of an airplane called, where the crew and passengers sit? The main central body of the airplane is called the fuselage, holding everyone very safely. It connects all the major parts together, like the wings and the tail section correctly. 2. Which type of stress tries to pull an aircraft structural component apart during a flight? Tension is the specific force that tries to stretch or pull a component completely apart. When forces pull on opposite ends of a part, it creates a lot of heavy tension. 3. What kind of stress crushes or pushes an aircraft part tightly together, causing a squeeze? Compression is the crushing force that pushes the materials together, reducing their overall physical length. This happens to the landing gear struts when the heavy airplane rests on the ground. 4. What do we call the twisting force that affects the airframe during flight maneuvers today? Torsion is the exact twisting force, similar to wringing out a wet towel by hand. Engine torque and flight forces cause twisting motions, which the airframe structure must safely resist. 5. What is the common metal used to build most aircraft structures because it is light? Aluminum alloys are mostly used because they are lightweight and incredibly strong for their size. Pure aluminum is too soft, so it is mixed with other elements, making it much stronger. 6. Which modern aircraft material is lighter than aluminum and used in many new airplane designs? Carbon fiber composite material is very light, and it is used to build newer airplanes. Composites are made of strong fibers baked in resin, offering great strength and low weight. 7. What is the name of the long metal pieces running lengthwise inside the aircraft fuselage? They are called stringers, and they help the aircraft skin keep its correct, aerodynamic shape. Stringers carry some flight loads, and they prevent the metal skin from bending or buckling. 8. What is the name of the main structural beam running inside the length of a wing? The spar is the primary structural beam, carrying the heaviest bending loads during the flight. Spars are the backbone of the wing, supporting the ribs and the outer metal skin. 9. What parts give the airplane wing its special curved shape, helping the plane fly smoothly? The wing ribs are the structures that form the special curved shape of the wing. Ribs attach to the main spars, transferring the airloads from the skin to the spar. 10. What is the entire tail section of an airplane officially called, in modern aviation terms? The entire tail section is officially called the empennage, located at the back of airplanes. The empennage provides stability and control, keeping the airplane flying straight and perfectly level always. 11. Which moving part on the tail helps the airplane steer left and right during flight? The rudder is the moving part that helps the pilot steer the airplane left or right. Pushing the foot pedals inside the cockpit moves the rudder on the vertical tail fin. 12. What do we call the damage caused by constant stretching and bending over many years? Metal fatigue is the damage caused by repeated bending, making the airplane structure very weak. Just like bending a wire repeatedly, metal parts will eventually crack after many stressful flights. 13. Why are most airplane passenger cabins pressurized during high-altitude commercial flights across the world? Cabins are pressurized so passengers can breathe normally, because outside air is thin and cold. The airframe acts like a pressure vessel, holding thick, breathable air safely inside the cabin. 14. What kind of landing gear setup features a nose wheel and two main wheels behind? Tricycle landing gear is the setup, with one wheel in front and two wheels behind. This modern design makes steering on the ground much easier and prevents the plane tipping. 15. Why do aircraft mechanics look closely for a powdery white substance on the metal skin? White powder is a clear sign of aluminum corrosion, which is a type of rust. Corrosion eats away the strong metal, weakening the airframe and causing major safety risks overall. 16. How do engineers protect the aluminum airplane parts from wet weather and bad, dangerous corrosion? They apply special chemical coatings and strong paints, sealing the metal from dangerous water damage. Keeping the metal dry is critical, and drain holes help remove trapped water from inside. 17. What are the heavy wall structures inside the fuselage that provide extra strength and support? Bulkheads are the internal walls that add strength and separate different sections of the airplane. A pressure bulkhead at the back seals the cabin, keeping the comfortable pressurized air inside. 18. Which structural design uses the outer metal skin to carry part of the flight stresses? The semi-monocoque design uses the outer skin, along with internal frames, to carry stress. This method makes the airplane very light, but incredibly strong, distributing loads across the surface. 19. Why is titanium used around the engine areas instead of using normal, cheaper aluminum alloys? Titanium is chosen for engine areas because it can withstand extremely high, dangerous heat levels. Aluminum melts at high temperatures, but titanium stays strong, making it perfect for hot engines. Please remember to check the video description below to get the full course and learn more. Welcome back to Section 2 of our Aviation Aircraft General Airframe course for the year 2026. Now, we will look closer at how the airplane actually moves and steers in the sky. The pilot uses primary flight controls to change the direction of the flying airplane safely. These controls are moving surfaces attached to the back edges of the wings and the tail. We have three main directions of movement, which are called pitch, roll, and yaw, right now. First, let us talk about pitch, which is the nose moving up or moving down smoothly. The pilot pushes or pulls the control wheel to move the elevators on the back tail. When the elevators point up, the wind pushes the tail down and the nose goes up. Next is roll, which is the airplane tilting from the left side to the right side. Ailerons are on the outer wings, and they move in opposite directions to make it roll. If the left aileron goes up, the right one goes down, pushing the left wing lower. The third movement is yaw, pointing the nose left or right, like turning a driving car. The pilot pushes the foot pedals, moving the rudder, which is on the vertical tail fin. To turn the airplane smoothly, the pilot must use the ailerons and the rudder together perfectly. Now, we have secondary flight controls, which help the airplane fly better at much slower speeds. Flaps are big moving panels on the inner back edge of the main airplane wings. Today, when the flaps slide out, they make the wing bigger, creating more lift for the airplane. This extra lift allows the airplane to fly very slowly without falling out of the sky. Pilots always use flaps for landing so they can touch down safely on a short runway. Slats are very similar to flaps, but they are located on the front edge of the wings. Spoilers are metal plates on top of the wings that pop up to kill the lift. When the airplane lands, spoilers pop up quickly, keeping the heavy plane firmly on the ground. They also act like speed brakes, slowing the airplane down while it is flying very fast. Most modern passenger airplanes use hydraulic systems to move all these heavy control surfaces with ease. A hydraulic system uses thick liquid under very high pressure to push heavy metal parts around. Imagine pushing water through a tube to move a heavy box on the other far side. airplane engines turn hydraulic pumps, which squeeze the liquid, making it very strong and powerful. If the pilot moves the control wheel slightly, the hydraulic fluid does all the heavy pushing. Because safety is our main goal, airplanes have 3 or 4 separate hydraulic systems running together. If one hydraulic pump breaks down entirely, the other backup pumps will keep the airplane flying. Mechanics must keep the hydraulic fluid clean, because tiny dirt pieces can ruin the expensive pumps. The landing gear also uses this hydraulic fluid to fold up inside the airplane after takeoff. Retracting the wheels makes the airplane smooth, saving a lot of fuel during a long flight. Before landing, the hydraulic fluid pushes the heavy gear back down, locking it into place safely. I want you to remember how all these systems work together to make flying very safe. The airframe holds the controls, and the hydraulics move them, giving the pilot total command, always. 20. What are the controls called that change the main direction of the flying airplane? They are called primary flight controls, managing the pitch, the roll, and the yaw correctly. The pilot uses these main surfaces to safely steer the aircraft through the open sky. 21. Which flight movement involves the airplane nose pointing directly up or pointing directly down? This up and down movement is called pitch, controlled by the elevators on the tail. Pulling the wheel back raises the elevators, pushing the tail down and the nose up. 22. What is the tilting movement called, from the left side to the right side, during flight? This tilting motion is called roll, helping the airplane turn left or turn right smoothly. The ailerons on the outer wings control this specific rolling motion during all normal flights. 23. Which control surface makes the airplane roll by moving in opposite directions on the main wings? The ailerons make the airplane roll by moving up on one side and down opposite. When one wing gets more lift, the other gets less, causing the airplane to tilt. 24. What is the side-to-side movement called, where the nose points left or right? This movement is called yaw, acting just like steering a car on a flat road. The rudder controls the yaw, keeping the airplane nose pointed straight in the right direction. 25. Which moving part on the vertical tail fin controls the yaw movement of the airplane today? The rudder is the specific part that controls the yaw when you push the pedals. Pushing the left pedal turns the rudder left, moving the airplane nose to the left. 26. What do we call the extra moving panels that help the airplane fly at slower speeds? These are called secondary flight controls, including the flaps, the slats, and the wing spoilers. They change the wing shape, allowing safe flying when the airplane is not moving fast. 27. Where are the flaps located to help create more lift for landing the airplane safely? The flaps are located on the inner back edge of the main airplane wings, mostly. They slide out and down, increasing the wing area for much better slow-speed lift. 28. What moving surfaces are placed on the front edge of the wings to increase airplane lift? Slats are placed on the front edge, extending forward to help the airplane fly slowly. Just like flaps, slats change the airflow, keeping the airplane flying safely at low speeds. 29. What are the metal plates on top of the wings that pop up to kill lift? These plates are called spoilers, and they ruin the smooth airflow, pushing the wing down. Pilots use them to slow down or keep the plane on the ground after landing. 30. What kind of system uses high-pressure liquid to move heavy airplane parts very easily? A hydraulic system uses thick pressurized fluid to push heavy metal parts without human effort. This strong system does all the heavy lifting, giving the pilots complete, easy steering control. 31. What turns the hydraulic pumps, creating the high pressure needed to move the flight controls today? The main airplane engines turn the pumps, squeezing the fluid to create very high pressure. When engines are running, they provide constant mechanical power, keeping the hydraulic system fully active. 32. Why do passenger airplanes have 3 or 4 separate hydraulic systems working at the same time? They use multiple systems for safety, so a backup is always ready if one breaks. If one pump fails, the others take over, ensuring the pilot never loses steering control. 33. What happens to the landing gear after takeoff to save a lot of airplane jet fuel? The hydraulic system pulls the heavy landing gear up, hiding it inside the airplane body. Retracting the wheels reduces wind resistance, allowing the airplane to fly much faster and smoother. 34. What pushes the heavy landing gear back down before the airplane lands on the airport runway? The hydraulic fluid pushes the heavy gear down, locking it safely before the wheels touch. Strong mechanical locks hold the gear firmly, so it does not collapse, hitting the ground. 35. Why must airplane mechanics keep the hydraulic fluid totally clean during all regular maintenance checks? Tiny dirt pieces can easily ruin the expensive pumps, causing a dangerous system failure quickly. Filters are used to catch the dirt, keeping the flowing fluid pure and fully safe. 36. Which flight control surface must a pilot use, alongside the ailerons, to make a smooth turn? The pilot must use the rudder, along with the ailerons, to make a perfect controlled turn. Using both controls together stops the nose from sliding outward, keeping the passengers very comfortable. 37. How do spoilers act like speed brakes while the airplane is still flying in the sky? They pop up slightly into the wind, creating extra drag, which slows the airplane down. This helps the airplane descend faster, without gaining too much dangerous speed during the flight. 38. What connects the pilot control wheel to the heavy hydraulic valves in modern passenger airplane systems? Electronic wires or steel cables connect the wheel, sending signals to open the hydraulic valves. Moving the wheel tells the system where to push the fluid, moving the outer surfaces. Please remember to check the description section below to get the full course and learn more. Welcome back to Section 3 of our Aviation Aircraft General Airframe course for 2026. Today, we will talk about the air we breathe and the systems that keep us warm. High up in the sky, the air is freezing cold and extremely thin, lacking enough oxygen. If we opened a window, we would not survive. Without our special airplane climate control systems, airplanes use a system called pneumatics, which is just a fancy word for using hot air. This hot air comes directly from the jet engines, and it is called engine bleed air. The engines squeeze the outside air, making it incredibly hot, and pushing it out very fast. We take a little bit of this hot air, and use it inside the main airplane. First, the hot bleed air goes to the air conditioning packs, tucked under the airplane floor. These packs are like big refrigerators, cooling the super hot air down to a comfortable temperature. Then, this nice warm air is blown into the cabin, keeping all the passengers completely comfortable. The system constantly mixes fresh outside air with filtered inside air to keep everyone perfectly healthy. This same air is used to pressurize the cabin, blowing it up like a big balloon. To keep the pressure just right, we have a small door at the back, called an outflow valve. This valve opens and closes slowly, letting some air leak out, to perfectly balance the pressure. If the pressure gets too high inside, the metal skin of the airplane could stretch too much. If the pressure gets too low, the oxygen masks will automatically drop down, for the passengers. The pilots have complete control over this valve, using their computers, on the main flight deck. Next, let us look at ice protection, because freezing ice is a huge danger for flying airplanes. When flying through wet clouds, ice can freeze quickly on the leading edge of the wings. If ice builds up on the wings, it ruins the smooth shape, destroying the required lift. The airplane will become very heavy, and it could easily fall right out of the cloudy sky. To stop this, we use a hot engine bleed air to melt the dangerous ice away quickly. Tubes carry the hot air inside the wing edges, heating the metal so the ice melts off. Some smaller airplanes use rubber boots on the wings, inflating them with air to break the ice. The cockpit windows are also heated with electricity, so the pilots can always see perfectly clearly. Even the small speed measuring tubes outside have tiny electric heaters to stop them from freezing solid. Water drains on the airplane also have heaters, preventing freezing ice from blocking the normal water flow. Fire protection is another massive part of keeping our airplane airframe completely safe during every flight. The engines have special fire wires wrapped around them to detect unexpected heat or sudden flames. If a fire starts, loud bells will ring, alerting the pilots immediately inside the flight deck. The pilot can pull a handle, shutting off the engine fuel and spraying heavy fire extinguishing foam. The cargo holds underneath the passenger floor also have sensitive smoke detectors and big foam bottles. We build the cargo walls with special fireproof panels, stopping any flames from reaching the passengers above. Everything is designed to give the crew enough time to land safely at the nearest open airport. These systems run silently in the background, ensuring your flight is safe, warm, and highly comfortable. 39. What is the system called that uses hot pressurized air for various airplane functions today? It is called the pneumatic system, using very hot air from the main spinning engines. This hot air travels through metal pipes, doing different jobs all around the large airplane structure. 40. Where does the hot pressurized air come from for the airplane pneumatic system to work? It comes directly from the jet engines, and this air is called engine bleed air. The engines squeeze the outside air, making it hot, before mixing it with the jet fuel. 41. What do we call the big cooling machines tucked underneath the main passenger cabin floor? They are called air conditioning packs, and they cool down the extremely hot engine air. These cooling packs work like big refrigerators, sending nice comfortable air into the main passenger cabin. 42. How does the airplane maintain the correct air pressure inside the passenger cabin during flight? A small moving door at the back, called an outflow valve, controls the trapped air. By slowly letting some air leak outside, it perfectly balances the pressure for the breathing passengers. 43. What happens if the air pressure inside the airplane cabin drops too low during flight? Yellow oxygen masks will automatically drop down from the ceiling above the passenger seating area. Passengers use these masks to breathe pure oxygen until the pilot flies down to lower safety. 44. Why is a build-up of freezing ice on the wings very dangerous for a flying airplane? Ice ruins the smooth shape of the wings, destroying lift and making the airplane completely heavy. Without enough lift from the wings, the heavy airplane simply cannot stay up in the sky. 45. How do large passenger airplanes keep heavy ice from forming on the front wing edges? They blow hot engine bleed air inside the wing edges to melt the coldness. The hot metal surface prevents water from freezing, keeping the wing shape completely clean, always. 46. What system do smaller airplanes use to break the hard ice off their wing edges? They use inflating rubber boots on the wing edges, expanding quickly to crack the frozen ice. As the rubber boots puff up with air, the frozen ice shatters, blowing away almost instantly. 47. How do the pilots keep their large front cockpit windows clear from outside freezing ice? The thick glass windows have thin electric wires inside, heating up quickly to melt the ice. This constant electric heat keeps the windows totally clear, so pilots can see the runway clearly. 48. What outside airplane parts use tiny electric heaters to keep the speed measuring sensors working? The small pitot tubes use electric heaters, preventing ice from blocking their tiny measuring holes. If these tubes freeze totally, the pilots will lose their airspeed numbers, causing massive flight confusion. 49. How do we prevent wastewater from freezing when it empties out of the flying airplane? The water drain masts outside the airplane have small electric heaters to stop solid freezing. This ensures dirty water can safely flow out without creating huge, heavy blocks of solid ice. 50. What is wrapped around the hot jet engines to detect any dangerous fires during flight? Special heat-sensing firewires are wrapped around engines, looking for sudden flames or extreme heat. If these tiny wires get too hot, they instantly send a loud alarm to the pilots. 51. What will the pilot pull to spray extinguishing foam into a burning airplane jet engine? The pilot pulls a bright red fire handle, shutting off fuel and spraying heavy thick foam. Cutting the fuel stops the fire from growing, and the thick foam puts out the flames. 52. Where else are smoke detectors hidden, besides the airplane passenger cabin and the main bathrooms? They are installed underneath the floor, inside the dark, enclosed luggage and cargo hold areas. If a bag catches fire, the detectors warn the crew to easily release the cargo foam. 53. How are the walls of the airplane cargo holds built to keep the upper passengers safe? The cargo walls are built using strong, heavy fireproof panels, holding the dangerous flames back safely. These tough fireproof panels give the pilots plenty of extra time to land the airplane safely. 54. Why does the airplane constantly mix fresh outside air with the recirculated cabin air inside? Mixing fresh air keeps the cabin environment healthy and prevents the air from getting totally stale. Filters remove tiny germs from the inside air, keeping everybody breathing easily during very long flights. 55. What happens to the hot engine bleed air before it ever reaches the passenger cabin? The incredibly hot air must pass through the cooling packs, lowering the temperature to normal levels. If it did not cool down first, it would badly burn the passengers inside the airplane. 56. Who controls the main cabin temperature and the pressurization systems during a normal airplane flight? The pilots control these complex systems using simple switches and computers on the main flight deck. The computers do most of the hard work, but pilots monitor everything for complete total safety. 57. What is the main goal of the airplane fire protection and ice protection systems combined? The main goal is providing total safety, protecting the airframe from massive damage during mid-flight. These strong systems act as a heavy shield, allowing safe travel through bad weather or emergencies. Please remember to check the video description below to get the full course and learn more. Welcome back to Section 4 of our Aviation Aircraft General Airframe course for 2026. Today, we will learn about how the airplane stores its fuel and gets its electric power. These systems are incredibly useful, keeping the engines running smoothly and the bright lights completely on. Without heavy fuel and electricity, our giant metal bird would just sit on the dark ground. Airplanes need a lot of jet fuel to fly thousands of miles across the big oceans. Most of this heavy liquid fuel is hidden safely inside the empty spaces of the wings. We call these wing tanks integral tanks because they are built right into the metal structure. Sealing the metal joints tightly stops the smelly fuel from leaking out during the long flight. Some large airplanes also have center fuel tanks located inside the main body, under the floor. Inside these dark tanks, we have electric pumps, which push the liquid fuel to the engines. The engines burn this fuel, creating massive thrust to push the heavy airplane forward very fast. We also have special fuel pipes, allowing the pilot to move fuel between tanks during flights. Moving fuel helps balance the airplane, keeping it flying perfectly straight and level in the sky. If one wing side gets heavy, the pilot simply pumps some fuel to the other side. Now, let us talk about electricity, because modern airplanes are basically giant, flying supercomputers today. The main jet engines spin big generators, creating lots of electric power for the whole airplane. This power travels through miles of colorful wires hidden behind the walls and the overhead ceiling. We use this electricity to run the computer screens, the bright lights, and the coffee makers. If the main engines stop working, we have a small backup engine hidden in the back tail. This small engine is called the APU, and it provides emergency electricity, keeping the airplane safe. The APU also gives us hot air to start the big main engines before we fly. Deep inside the airplane belly, we have heavy batteries, just like the ones in your car. These batteries give us enough power to run the emergency radios if everything else completely fails. Circuit breakers protect the airplane wires, popping out to stop dangerous electrical fires from starting unexpectedly. Pilots can easily check these breakers on a large panel located right behind their cockpit seats. Mechanics inspect the wires very often, making sure the plastic covers are not rubbed or broken. Everything on the airplane is connected using heavy metal grounding wires to prevent bad static shocks. If a lightning bolt hits the airplane, the metal skin carries the electricity safely away outside. The lightning simply slides off the tail without ever hurting the passengers, sitting perfectly safe inside. We use bright flashing lights outside, helping other pilots see our airplane in the dark night. Red and green colored lights on the wings tell others which way our airplane is going. I hope you can see now how fuel and electricity bring the sleeping airplane to life. 58. Where do large passenger airplanes store most of their heavy liquid jet fuel during a flight? Most of the jet fuel is safely stored inside the empty spaces of the large wings. Keeping fuel in the wings helps balance the weight, making the wings stronger against flight bending. 59. What do we call the fuel tanks that are built directly into the metal wing structure? We call them integral fuel tanks because they are a solid part of the wing metal. The wing skin itself forms the tank walls, saving a lot of weight for the airplane. 60. How does the liquid jet fuel travel from the dark wing tanks to the running engines? Electric fuel pumps push the liquid fuel through metal pipes straight into the hungry jet engines. These strong pumps ensure the engines always get enough fuel to keep the heavy airplane flying. 61. Why would a pilot pump jet fuel from the left wing tank to the right wing? The pilot moves fuel to balance the airplane, keeping it flying perfectly level in the sky. If one wing gets too heavy, moving the liquid fuel easily fixes the bad weight problem. 62. What part of the airplane creates most of the electrical power during a normal passenger flight? The spinning jet engines turn large generators, creating most of the electricity for the whole airplane. These powerful generators act just like huge alternators, powering all the screens, computers, and cabin lights. 63. What is the small backup engine called, hiding safely in the back tail of the airplane? This small backup engine is perfectly called the APU, or the Auxiliary Power Unit, in aviation. The APU provides emergency electricity and hot air when the main jet engines are completely off. 64. What powers the emergency radios and lights if all the jet engines and generators break down? Heavy-duty batteries provide the final emergency power, keeping the main radios and lights working perfectly. Just like a car battery, they hold stored power, giving the pilots time to land safely. 65. What small devices protect the airplane wiring from getting too hot and starting a bad fire? Circuit breakers protect the long wires popping out to stop the electricity if things get hot. If too much power flows through a wire, the breaker stops it, preventing a huge disaster. 66. Where do the pilots look to check if an electrical circuit breaker has safely popped out? They look at a large breaker panel, mostly located right behind their comfortable front cockpit seats. This big panel lets them easily see and reset the electrical systems during a long flight. 67. What happens to the passengers inside if a scary lightning bolt strikes the flying metal airplane? The metal skin safely carries the dangerous lightning away, keeping everyone inside completely safe and unharmed. The airplane acts like a metal cage, letting electricity slide outside without coming into the cabin. 68. How do airplane mechanics prevent sudden static electricity shocks from hurting people or sensitive flight computers? They connect everything together with heavy grounding wires, safely sharing the static charge across the metal. Grounding ensures no single part builds up too much static, keeping all the smart computers safe. 69. What colors are the navigation lights located on the far tips of the main airplane wings? The left wing has a red light, and the right wing has a bright green light. These colored lights help other passing airplanes see exactly which direction we are flying at night. 70. What bright lights help other flying pilots see our large airplane easily during the dark night? Bright flashing strobe lights on the wings help everyone see our airplane from very far away. These bright white flashes are incredibly easy to spot, stopping any dangerous mid-air collisions from happening. 71. Why is it very important to seal the metal joints inside the integral wing fuel tanks? Sealing the metal joints perfectly stops the liquid jet fuel from leaking out during the flight. Mechanics use special thick rubber pastes to fill every tiny gap, keeping the heavy fuel inside. 72. What do we call the extra fuel storage area hidden safely beneath the passenger cabin floor? This hidden storage area is simply called the center fuel tank, holding extra heavy liquid fuel. Center tanks give the airplane much more fuel, allowing it to fly across the big oceans. 73. What travels through the miles of colorful wiring hidden behind the walls of the passenger cabin? Electrical power and computer data travel through these long wires, connecting every part of the airplane. These wires are the nervous system, sending power and commands to the engines and the lights. 74. Why do mechanics check the plastic covers on electrical wires during normal routine airplane maintenance checks? They look for rubbed or broken plastic, which could easily cause dangerous sparks or electrical fires. Protecting the bare metal wires is very critical, keeping the flying airplane completely safe from harm. 75. What system keeps the coffee makers running so the tired pilots can stay perfectly awake today? The electrical system powers the nice coffee makers, using electricity from the main spinning engine generators. Just like your kitchen at home, the airplane cabin needs stable electrical power for small appliances. 76. How does the small APU engine help the pilots before the main jet engines are started? The APU gives them electricity to run the screens and hot air to start the engines. It allows the pilots to set up their computers while sitting parked at the airport gate. Please remember to check the video description below to get the full course and learn more. Welcome back to Section 5 of our Aviation Aircraft General Airframe course for 2026. Today, we will learn about the heavy wheels and brakes that stop our flying airplane. We will also look at how we get fresh drinking water and safe breathing oxygen. The landing gear holds the airplane when it is resting safely on the hard ground. These heavy metal legs must absorb the massive shock of a very fast, hard landing. Inside the metal gear legs, we have thick oil and gas working like big springs. When the airplane touches down, the oil squishes slowly, making the landing feel very smooth. The wheels are made of strong metal, and they wear huge, thick black rubber tires. These tires do not have air, because we fill them with safe, dry nitrogen gas. Nitrogen gas does not catch fire, and it handles cold weather much better than air. To stop the heavy airplane, we use strong carbon brakes, located inside the main wheels. When the pilot pushes the pedals, hydraulic fluid squeezes the brakes, creating massive stopping friction. This friction makes the brakes extremely hot, sometimes glowing bright red, in the dark night. Anti-skid computers watch the wheels, stopping them from sliding safely on a wet runway. If a wheel starts sliding, the computer releases the brake slightly, keeping the airplane straight. Now, let us talk about the emergency oxygen system, hidden safely inside the passenger cabin. If the cabin loses pressure, yellow masks drop down, giving you safe air to breathe. Small chemical generators get very hot to create this emergency oxygen for the scared passengers. The pilots have their own oxygen bottles securely hidden behind the comfortable front cockpit seats. They wear special tight masks, protecting their eyes from thick smoke during a bad fire. Next, we must understand the clean water and waste systems built inside the airplane today. Clean drinking water is stored inside heavy heated tanks beneath the main passenger cabin floor. Pumps push this fresh water to the small bathroom sinks and the front coffee makers. We heat the water tanks so the clean water never freezes high in the cold sky. When you flush the toilet, a loud vacuum sucks the waste into a hidden holding tank. This dark waste tank is emptied by special airport trucks after the airplane lands safely. We never drop waste from the sky because that is totally illegal and extremely dangerous. Mechanics check the tires every day, looking for deep cuts or worn-out rubber threads. If a tire looks too old, we lift the airplane UP and change it quickly. Changing an airplane tire is just like changing a giant, heavy car tire right now. Pilots use a small steering wheel called a tiller to drive around the busy airport. This tiller turns the front nose wheels, helping the airplane park exactly at the gate. We must be very careful when driving such a giant machine around small airport trucks. Airplanes cannot drive backward easily, so special pushback tractors push them away from the building. The heavy tractor connects to the nose gear, moving the big airplane slowly and safely. Once the airplane is clear, the pilots can start the engines and begin their trip. All of these mechanical parts require daily oiling to stop the shiny metal from rusting. You can see how every system works perfectly together, keeping the flying airplane completely safe. 77. What heavy system supports the large airplane when it rests safely on the hard ground? The landing gear supports the airplane, absorbing the heavy weight during taxi and parking. These thick metal legs hold everything up, keeping the belly from scraping the hard runway. 78. What is hidden inside the landing gear legs to make the fast airplane landings smooth? Thick oil and dry gas are inside, acting like a giant, soft bouncing spring. The shock strut squishes down, absorbing the hard bump, making the passengers feel perfectly comfortable. 79. Why do we fill airplane tires with nitrogen gas instead of using normal breathing air? Nitrogen gas never catches fire, and it does not freeze high in the cold sky. Normal air has water inside, which freezes easily, causing the heavy tires to dangerously pop. 80. Where are the strong carbon brakes located to help stop the fast-moving passenger airplane? The strong brakes are installed securely inside the large main wheels on the landing gear. These heavy brakes squeeze together tightly, creating massive friction, completely stopping the rolling airplane. 81. What pushes the brake pads tightly together when the pilot presses the floor control pedals? High-pressure hydraulic fluid travels down, pushing the heavy carbon brake pads tightly together. This strong fluid does all the heavy work, saving the tired pilot from pushing too hard. 82. What happens to the strong carbon brakes when they stop a very heavy, fast airplane? The massive stopping friction makes the brakes extremely hot, sometimes glowing a bright cherry red. Carbon brakes love high heat, working much better when they get extremely hot during landing. 83. Which computer system stops the airplane wheels from sliding dangerously on a wet airport runway? The anti-skid computer watches the spinning wheels, preventing dangerous sliding during a rainy landing. Just like your modern car brakes, it pumps the pressure rapidly, keeping steering completely safe. 84. What happens if the anti-skid computer senses one airplane wheel is completely sliding today? It quickly releases the brake pressure slightly, letting the sliding wheel safely spin again. This smart system stops the rubber tires from blowing out, keeping the airplane tracking straight. 85. What hidden system gives you safe breathing air if the passenger cabin loses its pressure? The emergency oxygen system drops yellow masks, providing safe breathing air for all the passengers. You just pull the yellow mask tightly, activating the hidden flow to breathe very safely. 86. How does the passenger cabin oxygen system create the emergency breathing air during a flight? Small chemical generators burn very hot, creating fresh breathable oxygen for the scared passengers. These hot chemical cans start working instantly when you firmly pull the yellow dropping mask. 87. Where do the two pilots get their safe breathing oxygen during a very bad emergency? The pilots have huge green oxygen bottles, securely hidden safely behind their comfortable front seats. They need a larger, longer-lasting supply, giving them extra time to land safely. 88. Why do the pilots wear special tight masks over their entire faces during an emergency? These tight masks cover their eyes, completely protecting them from thick, blinding electrical fire smoke. The pilots must clearly see their screens, so the tight mask keeps the dark smoke out. 89. Where is the clean drinking water stored safely inside the large modern passenger airplane today? The fresh water is safely stored inside large heated metal tanks beneath the cabin floor. Electric pumps push this clean water everywhere, reaching the sinks and the busy coffee makers. 90. Why must the airplane clean water tanks and hidden metal pipes have small electric heaters? Electric heaters stop the clean drinking water from completely freezing solid high in the sky. The air outside is freezing cold, so heaters keep the useful water flowing very smoothly. 91. What happens to the dirty bathroom waste when you flush the toilet on an airplane? A powerful loud vacuum loudly sucks the dirty waste into a hidden dark holding tank. The airplane safely keeps the waste inside until special airport trucks remove it after landing. 92. Why do we completely ban dumping dirty bathroom waste from the flying airplane into the sky? Dropping dirty waste from the sky is totally illegal and extremely dangerous for ground people. All airplane waste is strictly locked away, completely stopping dangerous frozen ice blocks from falling. 93. What do the busy airplane mechanics look for when they inspect the heavy rubber tires? They look closely for deep cuts or heavily worn-out rubber threads on the surface. Finding a bad tire early allows them to fix it safely before the next busy flight. 94. What must mechanics do if they find an airplane tire that is completely worn out? They safely lift the heavy airplane wheel up and change the bad tire very quickly. Special hydraulic jacks lift the heavy gear, letting the mechanic slide the old tire off. 95. Why are the small nose wheels on the airplane not equipped with heavy stopping brakes? The nose wheels are used for safe steering, while the main wheels provide the stopping. Putting heavy brakes on the front nose wheels would easily cause the airplane to nosedive. Please remember to check the video description below to get the full course and learn more. Welcome back to Section 6 of our Aviation Aircraft General Airframe course for 2026. Today, we will finish our journey by looking at airplane doors and the daily safety checks. The doors on an airplane are incredibly special and very different from your house doors. When the airplane flies high, the thick air inside pushes hard against the heavy metal doors. Because of this high pressure, most airplane doors are shaped exactly like a giant plug. This plug shape means the inside pressure actually seals the door completely tight and shut. It is physically impossible for anyone to open the door while flying high in the sky. Around the edges of the door, we use thick rubber seals, stopping air from leaking out. Mechanics check these rubber seals daily because cracked rubber will cause a very noisy, bad air leak. Overwing exits are smaller emergency doors, located right above the wings, for very fast escapes. We also have heavy cargo doors, located underneath the floor, to load all the luggage. Now, let us talk about the thick airplane windows, which give you a nice, beautiful view. Airplane windows are never made of heavy glass, but are made of strong, clear acrylic plastic. They actually have 3 separate plastic layers to handle the massive pressure and the cold weather. The outer layer takes all the heavy stress, while the middle layer acts as a strong backup. The inner layer is just a simple scratch cover, stopping passengers from ruining the main windows. You might notice a tiny hole located at the bottom of the middle plastic window layer. This tiny breather hole safely balances the trapped air pressure between the different plastic window layers. Before any airplane can fly, the pilots must walk around it, doing a careful visual inspection. This walk-around check is very important to catch any visible damage before starting the engines. They look closely at the metal skin, searching for missing screws or small dangerous bird strikes. Pilots also check the heavy landing gear tires, making sure there is no leaking red hydraulic fluid. If they see thick white frost on the wings, they must call the special dicing trucks immediately. These trucks spray hot green liquid, melting the dangerous frost and cleaning the smooth wings perfectly. Once the outside is fully checked, the pilot climbs back inside to finish the computer setup. Airplane maintenance is very strict, requiring mechanics to check every tiny part on a tight schedule. A check happens every few days, but heavy checks happen every few years, taking planes completely apart. During a heavy check, they remove the seats and use special X-ray tools, looking for hidden cracks. This careful process guarantees that old airplanes remain just as safe as brand new flying airplanes. I am very proud of you for learning all these complex airframe systems with me today. You now know how the airframe is built, how it moves, and how it keeps you completely safe. Remember to study these questions carefully, and you will definitely pass your big aviation exams easily. Thank you for joining my class, and I hope you have a wonderful, successful career in aviation. 96. Why are most modern passenger airplane doors shaped perfectly like a giant thick plug today? The plug shape allows the high inside air pressure to seal the door completely tight. Because the door is bigger than the frame, pressure pushes it firmly closed, stopping accidental opening. 97. What makes it completely impossible for anyone to open the airplane door during a flight? The massive difference in air pressure pushes the plug door closed, locking it very securely. Human muscles simply cannot beat the heavy force of the pressurized air pushing against the door. 98. What do airplane mechanics use around the door edges to prevent the inside air leaking? They use thick rubber seals around the metal door edges, keeping the trapped air inside. If these seals get old and crack, they create a very loud, annoying whistling noise. 99. Where are the smaller emergency exit doors, usually located on a large passenger airplane today? These smaller emergency doors are conveniently located directly above the main metal airplane wings mostly. They give passengers a very fast way out, allowing them to slide safely off the wings. 100. What strong material do we use to make the thick, clear airplane passenger cabin windows? We use strong layers of clear acrylic plastic, instead of using normal, heavy breakable glass. Plastic is much lighter than glass, and it handles the high cabin pressure very easily. 101. How many separate plastic layers do most modern airplane passenger cabin windows usually have today? Most airplane windows have 3 separate plastic layers, providing amazing strength and total passenger safety. Having multiple thick layers ensures that if one breaks, the other layers still hold the pressure. 102. What is the main purpose of the tiny hole, located in the middle window plastic layer? This tiny breather hole safely balances the trapped air pressure between the different plastic layers. It stops the middle plastic sheet from breaking, keeping the outer layer taking the heavy stress. 103. What important visual task must the pilots complete before they start the main jet engines? The pilots must walk around the airplane outside, looking for any visible damage or leaks. This walk-around inspection is a strict rule, ensuring the airplane is fully safe to fly. 104. What are the pilots looking for when they closely check the metal airplane skin outside? They look for missing metal screws, deep dents, or dangerous hidden bird strike damage completely. Hitting a big bird during landing can seriously dent the metal, requiring an immediate mechanic check. 105. Why must the pilot quickly call for a dicing truck during a cold, freezing winter morning? Thick white frost ruins the smooth wing shape, destroying lift, so it must be melted. The dicing trucks spray hot green liquid, completely removing the dangerous ice, for safe flying. 106. What do mechanics look for under the landing gear during a normal daily visual check? They look closely for red hydraulic fluid leaking from the heavy metal landing. Gear legs. A bad fluid leak means the heavy brakes or steering might not work safely during landing. 107. How often do mechanics perform small, routine safety checks on a busy flying passenger airplane? Small routine checks happen every few days, keeping the airplane fully safe for daily flying. These fast checks focus on the tires, the oil, and the busy flying control surfaces. 108. What happens during a heavy maintenance check, which takes place every few flying years today? Mechanics take the airplane completely apart, looking for deep hidden cracks inside the metal bones. They remove all the soft passenger seats, giving them full access to the hidden internal frame. 109. What special medical style tools do mechanics use to find tiny cracks inside the metal? They use special X-ray tools, letting them see directly inside the thick aluminum metal. This finds hidden metal fatigue completely early, stopping the wings from unexpectedly breaking during a flight. 110. Why do we use heavy cargo doors underneath the main passenger floor on large airplanes? These large cargo doors allow busy workers to easily load heavy passenger luggage and freight. They open very wide, letting the airport loading machines slide big containers inside the belly. 111. What keeps the heavy plug doors from falling outside when the internal cabin pressure is low? Heavy metal hinges hold the door perfectly in place when the airplane sits on the ground. The hinges help the crew swing the heavy door open so busy passengers can safely board. 112. Why is airplane maintenance considered one of the strictest safety systems in the modern world? Strict rules completely guarantee that every single part is checked long before it breaks unexpectedly. This extreme care means old flying airplanes remain incredibly safe throughout their entire flying lifetime. 113. What happens to the inner plastic window layer if a passenger accidentally scratches it? The inner layer gets scratched, but the main thick pressure windows remain completely safe outside. This thin inner scratch shield is very cheap, and mechanics can replace it incredibly easily. 114. How does studying these airframe systems help you become a certified, safe aviation mechanic today? Knowing these complex systems perfectly helps you pass your exam.